So what we're going to be doing here in this lesson, we learned how to solve systems of equations, and now we're going to be applying this to some word problems. You notice here our first two are going to deal with distance formula, so we'll review that and the interest formula. So let's review those really quickly. We know that the distance formula is rate times time equals distance, and then the interest formula we learned was principal times rate times time equals interest. Now we've done problems like this before and we just used one variable and we would find a relationship between that variable. These actually turn out to be a little easier now that we can solve systems of equations. So what we'll do is we'll do an example of each of these and then we'll do something that's a little new to us, dealing with just number problems. And so let's get started with this. This says two buses that are 412 miles apart head towards each other. One travels 3 miles per hour slower than the other, and they meet in 4 hours. What is the average speed of each bus? Now, in the past, we would come up with one variable and then try to relate them. And but what we can do here, we're looking for the speed of each bus. So all we need to do, we'll have two separate variables. So what we can do is we can let maybe x equal the rate or speed of the first bus, and then y can equal the rate of the second bus. Because that's what we're using those two variables because that's what we want to find. We want to find the average speed or the rate. Now, right away, we see a relationship between the speeds. So even before, instead of putting first bus, we can put faster and slower. The F and the S still work out. And so one travels 3 miles per hour slower than the other. So if x is our faster bus, is the rate of our faster bus, so we know that x will equal the rate of the slower one, and if you add 3 to that, that'll be the same. So the slower one plus 3 equals the faster. We also could have done the faster one minus 3 equals the slower one. Each will work. We are still going to set up a table like we did before. So here I did use first and second, so I didn't have to put faster and slower, but we'll still keep it like this. And we'll fill in our different blanks here. The rate of our first one or our faster one is x, and the rate of our second one is y. The time, so let's read through this again. Two buses that are 412 miles apart head toward each other. One travels 3 miles per hour slower than the other, and they meet in 4 hours. So they leave and they meet in 4 hours. So their time is 4. And so the distance of the first one is 4x. The distance of the second one is 4y. And we know, so they're in two different places. They're 412 miles apart, and they're heading towards each other. And so when they meet, their total distance added together will be 412. So we can make an equation out of that. So we can say 4x, the distance of the first one, plus 4y, the distance of the second one, is equal to 412. And also we had this equation here, x equals y plus 3. That was the relationship of the rates. Well, this looks like it's set up pretty nicely for a substitution. Now this one, if you notice, everything here is divisible by 4. So I would probably go ahead and divide both sides by 4, which will give us a little simpler problem. So dividing both sides by 4 is really dividing each term by 4. So this is really x plus y, and 4 into 412 would go 103 times. And then we have x equals y plus 3. And we'll go ahead and use substitution here, which we learned in a previous lesson. So we can take this, x is equal to y plus 3, and substitute it in there. So we have y plus 3, that's our x, plus y equals 103. And we have like terms, so this is 2y plus 3 equals 103. Subtract 3 from both sides, we would get 2y equals 100, and dividing both sides by 2, we get y equals 50. So y equals 50. If we come back up here, y equaling 50, that was our slower bus, so one bus is 50 miles per hour, and then to find the faster one, we simply take y and add 3 to it. So we have 50 miles per hour is one bus, and 53 miles per hour. And that is our answer, because we were trying to find the rate of each bus. So it's nice that we can just solve a system of equations there. Next one has to do what we talked about, the interest. And we learned that principal times rate times time is equal to interest. And so let's look through this one. Mr. Perry has a total of $10,000 invested in 2 accounts. The older account pays 8%, while the newer one pays 10%. How much does he have invested in each account if his total annual interest is $850? Well, we're trying to figure out how much is invested in each account. In the past, we would say maybe x is in one and then 10,000 minus x is in the other, but now that we have systems of equations, we can just use 2 variables. So we might say x is the amount in one account, and they describe these as the older and the newer. And then we could use y is the amount in the newer account. How much does he have invested in each account? We know that his total interest is $850. That's taking the interest from one and the interest from the other. Well, we can set up a table like we have in the past, and we're using principal times rate times time is equal to our interest. So we can go ahead and start filling this out as best we can. And we have our older account. How much principal? Well, that's x. The rate in the older account was 8%, so we can put 0.08. It tells us about annual interest, so that's every year, so we'll just put 1 for 1 year. And then our interest earned there, we're just going to multiply across, and we have 0.08x, because if you do x times 0.08 times 1, you get 0.08x. The newer account, the amount we have in our newer account, is y. That's 10%, which is 0.10, which is just really 0.1. That's also in for a year because it's talking about annual interest. And so we multiply across there, you get 0.1y. And we know that the total here is going to be $850, our total interest. We also know over here that our total principal is $10,000. And so we can use this column right here to write an equation. X plus y is equal to 10,000. And then we can use this column right here to write an equation. The interest from our older account plus the interest from the newer account equals 850. So 0.08x plus 0.1y is equal to 850. Now what we might want to do is, if you don't like working with the decimals, we can multiply both sides by 100, because we want to move this decimal over twice. So we're going to multiply this by 100, and we'll get 8x plus 10y equals 85,000. This one will keep the same. And actually, let's not keep it the same. Let's go ahead and multiply this one. Now that we have this one, let's eliminate. We're going to eliminate the x's. So we would multiply this by a negative 8, which would make this negative 8x, negative 8y, and negative 8,000. And so now these are opposites. We can use elimination here. So here this is just going to be 0. Negative 8y plus 10y is 2y. And 85,000 minus 80,000 is just 5,000. And so we can divide both sides by 2. And 5,000 divided by 2 is 2,500. And that tells us there's 2,500 in the newer account. So 2,500 in the newer account. And then we can either go back to this equation and figure out how much is in the older account, or we can just think through this. If we had 10,000 total, 2,500 is in the newer account. We can do 10,000 minus 2,500 and realize that there is 7,500 in the older account. And that is what the question was asking. And so there's our answer. So again, we found the 2,500. We can put it back in for y right here and solve for x, and we figure out that 7,500 in the older account. So both of those are familiar type problems. We could have done them in the past. We would have just used one variable and found a relationship that we could have used. But with solving systems of equations, it's a little easier because we can use two variables. This last one here is a new type of problem. And it's just a number problem. The sum of the digits of a two-digit number is 11. The difference of the number and a number obtained by reversing its digits is 45. What is the original number? So really we're looking for a number, a two-digit number, but the things that make this different is we're working with the digits. So what we're going to do is we're going to have our variables represent the digits. And we'll talk through this a little bit, but we'll let t equal the tens digit. And then sometimes we say the ones digit, but if we used an O, it looks like a 0, so we'll say the units digit, so we'll let u equal the units digit. And the reason we do this, so we're going to just do a quick review of what you probably learned quite a bit ago, is dealing with place value. And so if you had the number 32, 32 we can say is 3 times 10 plus 2 times 1. And so this 3, thinking about this over here, that would be our tens digit, because that's the tens digit, and then the 2 is the units digit. And so reversing these digits would give us 23, and we can think, well, that is 2 times the tens digit plus 3 times the units digit, or 3 times 1. I think I said that wrong. 2 times 10. So what we did here is we switched these places. So we switched the tens digit and the units digit. And so that's what we're going to end up doing over here when we work through this. So first of all, we know it's pretty easy. The sum of the digits of a two-digit number is 11. I'm going to write that down here because we're going to do a little bit work first, but the tens digit plus the units digit has to equal 11. We probably could work through this problem to figure it out just by guess and check, but we're going to use our systems of equations just for some practice here. It then says the difference of the number and the number obtained by reversing its digits. So let's say our original number, and we're going to come out with an expression for that and our reversed number. I could have just put the second number. So our original number is going to be the tens digit. It's kind of going to be like this. We had a 3 and a 2, but we don't know what the answer is, so we're going to say the tens digit times 10, so like we did here, plus the units digit, which in this case was 2, but we don't know what it is, so we're going to put u times 1, and we'll simplify this a little bit, and this would be better written 10t plus u. And now the reversed number, because we want to figure out the number obtained by reversing the digits. Well, to reverse the digits, we simply switch the t and the u. So instead of having 10t plus u, we will have 10u plus t. Now, what does it say about these two? The difference of the number, the original number, and the number obtained by reversing its digits is 45. So the difference, so we're going to take our original, which is the 10t plus u. That's our original right here, 10t plus u. And we want the difference, so we're going to subtract the reversed one, which is 10u plus t. And it says that difference is 45. And what we can do is we can simplify this. Notice real quickly before we simplify it, we do have two equations with just two variables. So this is going to be solvable using maybe substitution or elimination. So let's simplify this one. This, we can distribute the negative. Actually, let's just keep coming down here. So we have 10t plus u. Distributing the negative, we get minus 10u minus t equals 45. And then we have like terms, 10t minus t is 9t. U minus 10u is negative 9u equals 45. And now we have t plus u is 11. And from this, we have 9t minus 9u equals 45. And this one looks nicely set up to use elimination. We can go ahead and multiply the top one by 9. Both sides by 9. I will say we could have divided the bottom one both sides by 9. That's another thing you could do. So over here we get 9t plus 9u equals 99. And from this one, we're just going to keep this the same. 9t, sorry about that, let's minus 9u equals 45. And we can go ahead and do elimination because we have opposites here. So we have 18t is equal to 144. And dividing both sides by 18, we get 8, I believe. 144 divided by 18, 8, 4, add the 6, and 14. So we get 8. So our tens digit is 8, which coming back over to here, if this is 8, this 8 plus what equals 11? The units digit has to be 3. And so the question is, what is the original number? Well, the original number is 83. That's our answer. We can check it really quick because the 83 from this sentence, the difference of the number and the number obtained by reversing digits, so reverse these, you get minus 38. And it should be equal to 45. And if you subtract those, you do get 45. So 83 is the original number. And that's how you solve problems like that. It's a little different, so you're using tens digit and units digit. And a lot of times in these types of questions, it will ask you for the original number and then the reverse. The original is a 10t plus u. The reverse is 10u plus t. And so that's solving some word problems using systems of equations.